Welcome, class. Thank you for joining me for our first notes in Chapter 5. So Chapter 5 is all about polynomials and polynomial functions. Now, to get started, this chapter is going to have a lot of new vocabulary for us. So, to begin, I really want to take a little bit of time to explore the vocabulary, so as I'm using it throughout these videos, you're aware of exactly what I mean with each word. So, the first word I want us to look at is monomial. So, a monomial is a real number, variable, or a product of a real number and variable with whole number exponents. Now, really wordy. All it means is it's a single term, okay? So it can be just a number. It can be a number and a variable. The variable can have an exponent, or it can even have more than one variable. All of those are considered monomials. So you've seen polynomial expressions before, so really think of it as just a single term, okay? Now, the term degree. So degree of a monomial. What that's talking about is the exponent on the variable. So, for example, this term here has a degree of 6 because that is the exponent on the variable. This has a degree of 2 because it has an exponent of 2. Now that 5x, we say it has a degree of 1 because we know whenever there's no exponent, secretly it is a 1 there. And we say that any constant has a degree of 0. Okay, 0 because the variable's not even there. All right. So again, when referencing degree, that's what we're talking about. We're talking about the exponents that you see, or in the case of degree 1 and 0, of what you don't see. Polynomial is a monomial or a sum and difference of monomials. So this is what you're used to seeing. 4x squared minus 3. In fact, you saw that a lot last chapter, right? An example of a polynomial of degree 2. Here's another chain of monomials put together. So basically, it's monomials being connected with pluses and minuses. That's what is creating these polynomial expressions. Now, in terms of the degree of a polynomial, so we already discussed that degree is referencing the exponents. Now, to be the degree of the polynomial itself, we are looking for the largest exponent. So in this case here, the largest exponent in that polynomial is 2. So we say that the polynomial has a degree of 2. The next one we say is a polynomial of degree 4 because you see the largest exponent is a 4. As we progress through this chapter, you're going to see just how important that degree is. It tells you a lot about a function before you even look at the graph. So it is very important to understand what the degree of the polynomial is referencing. Now, if you flip to the next page, standard form of a polynomial. The standard form arranges the terms by degree in descending order. So what that means is you are starting with the highest degree, the highest exponent, and then you're writing the terms in descending order from there. So for example, 3 is the largest one there. So we start with a 3, then to 2, then to 1, then to the constant, which is degree 0. Okay, so that's all standard form means. Arranging the order, so you're starting with a term with the highest exponent and writing it from there. Now, while on the topic of these exponents, these degrees, there's ways of classifying polynomials, ways to name them. So, if you reference this chart here on classifying polynomials, there are 2 ways to name polynomials, okay? The first way is by the degree, okay? So, looking at that list, Something of degree 0 we call a constant. Now again, remembering degree 0 just means when you're talking about a number without a variable. Okay, that's degree 0. And we call that a constant polynomial. When we're talking about degree 1, we're talking about something that we call linear. Now, we are really good with linear things. You've been working on that for years. So that term you should already know, a linear polynomial. Quadratic, you should also know that. Degree 2, we just spent an entire chapter working on quadratics. So that vocabulary term should also be familiar to you. The next one, degree 3, we're going to call a cubic function, a cubic polynomial. Then degree 4, we call quartic, okay? And finally, degree 5 is a quintic polynomial. So there's a list of all of the ways we can name polynomials based on the degree that we see. Now, the other way to name it is based on the number of terms, okay? So monomial, we've already seen the vocabulary word, okay? Monomial is just a single term, okay? Just a number with an exponent or a number with a variable. Binomial, that prefix bi means two terms. Now here we're back down to a monomial again, a single term. But look at the next one, tri. Now again, tri, think triangle. Think 1, 2, 3 terms. Okay? Binomial means 1, 2 terms. Then really we only have names for those first 3, okay? After that, so notice this one has 1, 2, 3, 4 terms. We just start referencing it as polynomial of 4 terms, polynomial of 5 terms, so on and so forth. So the key here is when we're looking at these, we need to give them 2 names. So, for example, this one right here, you can see is a cubic trinomial. Okay, cubic because it has degree 3, trinomial because it has 3 terms. So we really want to get accustomed to those names, familiar with those names. Now, as you're working through your practice work, and even as we're looking at these slides, I'd recommend going back and re-referencing that table so you understand how to name them, because that is a big piece of understanding this chapter. So let's look at our examples. So we want to write each polynomial in standard form and then name it based on degree and number of terms. So looking at that first one. So the first one, the highest degree I see, the highest exponent is a 2. So I'm going to write the 9x squared first. Then I go to the next one, the 3x. And then finally, the constant is always going to be last, that number by itself. Okay, so I've arranged it based on the exponents. So successfully in standard form. Now I'm going to name it based on the degree and number of terms. So based on degree, I see degree 2 here. So if you go back and reference the table, degree 2 means it is a quadratic. Next, I'm going to name it based on number of terms. So I see 1, 2, 3 terms. So it's going to be a trinomial. All right, looking at the next one. So this one, the highest degree that I see is the 4, okay? So I'm going to write the x to the 4 first. Now, the next highest exponent that I see is x squared. Now, notice I have two of them, okay? So that's leaving a little bit of a predicament. That means you need to combine like terms. That's kind of the other piece we need to be considering here, is when you see the same exponent referenced more than once, that means you're looking at like terms. So that means I want to combine those to be 4x squared. I have negative 6 of them and 10 of them, so that combines to 4x squared. So the next largest is the x term, so 4x, and then finally the constant at the end. So again, the new piece there is not only for standard form are we talking about putting it in order, but we're also kind of referencing combining like terms, okay? So let's name it. So based on the degree 4, if you look up at your table, degree 4 means quartic. And if I name it based on number of terms, 1, 2, 3, 4, 4 terms. Now, recall that doesn't get a special name. All we say when there's 4 is polynomial of 4 terms. The naming only goes up to the 3. Beyond that, we just say polynomial of 4 terms, 5 terms, 6 terms, so on and so forth. All right, one more practice. So again, first, putting it in standard form. Well, the largest degree I see is at 3, so I'm going to write the 5x to the 3 first, then the 2x, and then the minus 1. So put it in standard form. Now I'm going to name it based on degree. Well, I apologize for that. I see a 3 there. So to me, that is saying that we're looking at something cubic. I see 3 terms. That is going to be a trinomial. So again, I would be referencing that table to help you if you're ever getting confused at how to name them, okay? Because every word I expect you to know in the naming process is going to be in that table. Now, to wrap up these notes, a cool little thing that we can do. So, we can determine degree based on looking at the data, okay? I can tell you the degree of the polynomial that generated that data just by doing this process, okay? So, what we want to do is, if I give you a data set, so here I just have a list of x and y's, and I want to know, what is the degree of the polynomial that made that? So, what you want to do is you want to line up all of the y values, okay? So all of these values right here, you want to line up. Now, why are we doing that? Well, because I want to start looking at the differences between them, okay? So, to find the differences between them, here, the difference between -1 and -7 is -6. -7 and 3, the difference is 4. The difference between -3 and 5 is 8. The difference between 5 and 11 is 6. 11 down to 9 is negative 2. Then down to negative 7 is negative 16. So we take all the differences and get that. So really we're just seeing negative 1 plus or minus what gets me to negative 7. The negative 7 plus or minus what gets me to negative 3. So all you're doing, finding the differences between them. Okay? So now notice those aren't the same yet. Okay? We're looking at different numbers still. So we do that process again. So the difference between negative 6 and 4, well, you have to add 10. The difference between 4 and 8, you have to add 4. Difference between 8 and 6, you have to subtract 2. 6 and negative 2, you have to subtract 8. Negative 2 and negative 16, you have to subtract negative 4. Now notice, you're still looking at different numbers here, okay? So finally, we get to this column. 10 down to 4 is minus 6. 4 down to negative 2 is also minus 6. Negative 2 down to negative 8 is negative 6. Negative 8 down to negative 14 is negative 6. And now finally, look at the numbers that we generated. Finally, all of those differences are the same. So what that means, because that is the third column of differences, that means the degree is going to be 3. So that's telling me, is this data came from a cubic function? Because I could keep taking the differences between y's, and on that third difference, the differences were constant. And that's communicating to me that this is a cubic function. So let's try one for ourselves, okay? So I'm going to start by just listing out all of my y's. 23, negative 16, negative 15, negative 10, negative 13, negative 12, and 29. And I want to start looking for the differences. So 23 down to 16. That's a difference of minus 39. Negative 16 up to negative 15. That's a difference of 1. Negative 15 up to negative 10 is a difference of 5. Now 10 back down to negative 13 is a difference of minus 3. Negative 13 up to 12 is a positive 1. And then negative 12 up to 29 is a difference of positive 41. So that's our first difference. Okay, now notice they're all different. So what that means is we have to do this again. So negative 39 up to 1 is a difference of 40. The difference between 1 to 5 is 4. 5 down to negative 3 is a negative 8. Negative 3 up to 1 is 4. 1 up to 40, or sorry, 1 up to 41 is a difference of 40. All right, so that is going to be our second difference. All right, now notice, we're still not looking at the same numbers, so we're going to have to do this process again. So between 40 down to 4 is a difference. You have to go down 36. 4 down to -8 is a -12. -8 up to 4 is 12. And 40, or 4 up to 40, is 36. Right, so that is our third difference. Now notice, we're still not looking at the same numbers. So let's try this again. -36 up to -12. You're going up 24. -12 up to +12, going up 24. 12 up to 36, up 24. There we go. Finally, with our differences, we have the same number. Now, that was all the way to the fourth difference. Okay? So because we made it all the way to the fourth difference in this calculation, what that's telling me is the function that made this is of the fourth degree. We are looking at a quartic function here. So that's a little process that you can do in order to figure out what the degree is of some data that you're looking at, and then name it. All right, so thank you so much for joining me. That is going to be all for this first set of notes. So please make sure you have all of this written down, and then come back to class and we will do our practice work together.